Okay, so today we're going to do a soldering demonstration. I'm going to show you three different types of soldering joints. One I call the perpendicular joint, the second one is a sweat solder, and the third one is a butt joint. A perpendicular joint is something like this, where we've got two pieces of metal soldered together. It's basically an edge to a face. The second solder joint that I'll show you is called a sweat solder, where we're soldering a face to a face. So there's two different discs of copper here, and we're basically just soldering them like pancakes, okay? And the third type of solder joint is one of the most common that we do, especially when we're making rings, and it's called a butt joint. And it's basically, where you're taking one piece of metal, rolling it around into a ring and soldering the ends closed. Okay, so it's an edge-to-edge solder joint. So those are the three different solder joints that I'll do. There's a whole world of different types of solder joint, but these three are ones that we kind of come across most often when we're making jewelry. So, but there's an infinite variety even in between these three solder joints. So don't think that these are the only types of solder joints that you'll ever do. We have four different types of solder in the studio. Hard solder is the one that we start with, and that melts at the highest melting temperature, 1450 degrees approximately. Medium solder is the next one that you would use that melts at 1360 degrees, then easy solder at 1325, and then extra easy at 1207. And the reason that we have four different types of solder is that it allows us to have at least four solder joints in a single piece. If you start with the hard solder that melts at the highest melting point, you can then solder another component onto that piece using medium solder, so that when that solder flows and gets that piece to attach to the first construction, that first solder joint won't fall off or just come apart. So it allows us to kind of step our way down, and you can have multiple solder joints on a single piece. So that doesn't mean that we can only have four solder joints. It's just the easiest way to get four different solder joints. In the studio, we have the solder designated by these little tags. So this is the solder, it's just wire form. They are designated by the different shape that they are attached to. So just visually, I can look at this and know that this triangle is telling me that this is medium solder. The easy solder is attached to a tag, circle tag. It also has the E stamped onto it, or easy on there. Hard solder is attached to a square or a rectangle, and extra easy is a hexagon. So you can just visually look at the different solders and you know that this is easy. Okay.
It is possible to design pieces of jewelry or objects that have multiple solder joints, more than four solder joints in a single construction.
You can build this construction using hard and medium, this using hard and medium, bring them together using easy. And that way you get five solder joints with only three different types of solder. So you have to think kind of strategically. It's kind of a puzzle. It's sort of what I like about metalsmithing. There's a lot of kind of logistics and mental gymnastics that you kind of have to play in order to get more complex structures. So let's get on to soldering. So the first solder joint that we're going to do is what I call a perpendicular joint. It is an edge of a piece of metal, a piece of sheet or wire that gets soldered to the face of another piece. Okay, so it looks sort of like this. Or we have this vertical piece here standing up, and the edge of this vertical piece is soldered to the face of this one. Just because I call it a perpendicular joint doesn't mean that it has to be 90 degrees. It can be any angle, but you're basically doing an edge to a face. So I've got a piece of copper here that this is going to be our face, and I like to solder up in the air. And so the tools that I use are this third hand, which is basically a pair of tweezers attached to this base. So I can place this piece of copper in the tweezers. And this allows me to, with my torch, come in with the heat from underneath. I can also bring the heat in from up above. So I have much more versatility in where I apply the heat. I could, and some people, if you take a class from somebody else, everybody has their own methods for soldering. Some people like to solder directly onto a flat surface. The problem that I have with that is, and I use it in some circumstances, but not every case. I like to try to get it up in the air, because if I'm just soldering on a flat surface, and I have this other piece of material standing vertically here, I can only bring heat in from up above. I can't get underneath it to apply heat from the bottom. So when possible, I try to work in the air. So I'm going to place this piece of copper in the third hand, and this is the second piece that I'm going to solder to this face. In a circumstance like this, where I have a vertical piece standing tall, I could place the second piece in a tweezers and just hold it here. I could get a second third hand and use the two third hands to kind of stabilize things. But for demonstration purposes, and when you're first starting out and when you're learning, it's nice to just kind of eliminate as much clutter on your work surface as possible. So what I'll do is I will just take this piece of material and just bend it into a U shape. And now it will stand up all by itself. Okay, so it's kind of this U-shaped joint, but it's still an edge to a face. So this is the way I'm going to solder this one together. When you're just learning, it's nice to kind of keep it simple and make it easy on yourself, because the more early successes you have, the less likely you're going to get frustrated. And learning to solder can be frustrating because it's all new. This isn't intuitive. So what I've just done is I've applied flux to both of these pieces. Flux comes in this container. This is called handy flux. There's different varieties of flux. I like the paste flux. And what we do is we apply flux to all of the surfaces, especially when you're working with silver. With copper, it's not nearly as important. You just need to have flux in the joints where the two pieces are going to come together. But it's just sort of standard practice for me to just flux the entire piece, because typically I'm working with silver, and that's when it becomes much more important to flux the entire piece. So this has a kind of a paste-like consistency. Flux has a tendency to dry out, especially this paste flux. So if it does seem to be getting a little bit dry, you can just use a little bit of water, add a little bit of water to the flux, and then kind of mix it up. Try to stir up that dry flux that dries out, and you should get it back to a paste-like consistency. Ideally, you would use distilled water, but we go through it pretty quickly in the studio at Carleton, so using just tap water is fine. Okay, once you get your flux on your pieces, you need to cut your pieces of solder. So because there's only one solder joint here, it's just a demo. I'm using medium solder. I know that because there's the triangle tag on here. But if this was going to be the first solder joint in a construction, that might have multiple solder joints, I would typically start with hard solder. But if you just have a single solder joint, it doesn't matter what you're using. One of the questions I get frequently is, how much solder do you need? You don't need to have a piece of solder that's equivalent to the length of the solder seam. The solder gets into the nooks and crannies of the material and binds to both pieces. It actually interacts with the molecular structure of both pieces of metal. But you don't need to have a piece of solder that's equivalent to that length. For something like this is probably 1 3/4 inch solder seam. So I usually cut my solder in 1/8 inch pieces, maybe 3/16 inch pieces. And for this, I'll probably use 3 pieces that length. One of the little tricks that I tell people is that if you think you need 3 pieces of solder, cut 4. Solder is cheap, and if you find that your solder doesn't flow all the way through the seam, then you can always add that fourth piece. If that fourth piece goes to waste, not a big deal. Okay, I'm going to bring in the heat, and what I'm going to do is I'm going to control the heat all the way around this piece. I need to bring both pieces of metal up to temperature at the same time. If one piece gets really warm and the other piece is not at soldering temperature, that solder is going to puddle onto the piece that reaches soldering temperature before it actually finds the seam, because both pieces have to be at the same temperature in order for the union to work. Torch control is everything. You really need to work on getting both pieces up to temperature at the same time. That's difficult when you're first starting out, and you will learn, everybody does, but it does take a little bit of time and practice. Okay, so we're going to come in with our heat. And the flux, as you warm the metal, goes through a couple of different phases. When you put it on at first, it's wet. So as we apply the heat, the moisture starts to boil out of the flux. Then it leaves behind kind of a cake-like consistency, like powdered residue. I call that the powdered donut stage. As you continue to heat, that powdered residue will start to glaze over on the surface, and then that is the glazed donut stage. So once you get to the glazed donut stage, that's where I bring in my solder. So I will hold off on bringing in the solder just yet until I get to that glazed stage. So let's start warming these things up, and you can see the liquid boiling out. And now we're at the powdered donut stage, okay? And as we continue to heat, that powder will start to glaze over. And notice how I'm applying heat from the top and the bottom. I need to get both pieces up to temperature. I always look at the mass of individual components. So that bottom plate is larger than the top component, but the top component is actually thicker in gauge than the bottom plate. So they're similar. I still think the bottom plate has more mass to it, but I do need to focus attention on that top piece as well. So right now I'm at the glaze stage, and I have my pieces of solder over here on this little crucible, and I'm going to use a pick to pick up my solder and apply it to the piece. You can use a pair of tweezers for this. I just find it a little more cumbersome to be working with two different tools. Also, if you are right-handed, try to learn to use the torch in your left hand, because you are much more nimble with your right hand because you write with that hand. And using these fine motor skills to push the solder around and get them into position, you're going to have far more control if you're using your right hand because you write that way. So the thing that I don't like to see happen is, because you are comfortable using your right hand, if you're a right-handed person, you start heating with your right hand with a torch in your right hand, and then when you go to apply your solder, you switch hands, either pick up a tweezers or pick up your pick and apply everything, and then you switch back over again. The reason I don't like to see that is because if something moves, then you have to switch again, pick the tools up and move things around, and then switch back. If you can learn how to use the torch in your left hand, your right hand is free to do all of these other things. So you're just much more efficient working that way. So if you're left-handed, you obviously do it the other way. Okay, I've got my crucible up here. It's a little awkward for me, but I'm gonna show you that my pick has flux on it. It's that black tip up here. That's flux. If it doesn't seem like there's enough, you can always dip into the flux and glaze over that pick a little bit. When the flux is warm, it's sticky. So I can heat up the tip of that pick. A little awkward because it's behind the tweezers for me. So I can use the pick to grab my solder. So here it is on the end of that pick, and I can place it just using the heat of the torch to warm the pickup so that it releases off of there. And you need to position the solder in, kind of around, and disperse the solder around the solder seam. I always think about the vantage point that the viewer is going to be looking at this. If this direction where the camera is now, if that's the vantage point that people are going to see the piece, put your solder on the back side, because if it happens to flow and puddle in a certain area, it will at least be somewhat camouflaged, because it will be on the back side. You're not seeing it from that vantage point. That's not always the case, so you have to just be very stealthy about the way that you put your solder in place. But always try to solder from the back side of something, or just do the best you can. For this, again, demonstration purposes, it doesn't really matter. I've got 2 pieces of solder in place. I'm going to grab this third one, and I'm going to place it over here. So we just want to snug these things up next to the solder seam, right down in that corner. Okay, I've got 3 pieces. I've got 1 over here and 2 over here. So now we're just going to continue to heat. And I'm coming in from above, coming in from down below. And I'm watching the flux. When that flux really starts to thin out and become really clear and level, that's a good indication that the metal is coming up to temperature. It's starting to look like that right now. So we're going to just continue to heat and see if we can get these 3 pieces to flow nicely. There they go. And now it just ran around the solder joint. So this one was a little tricky because the material thickness is a little bit different. The solder actually flowed over here. It flowed onto the backer plate first before it found the seam. Over here, it actually flowed onto the vertical piece before it found the seam. So I still have issues with these things. Not a big deal, but the solder finally got into the seam, and then it just shot around. You can actually watch it find that seam and run around. So once you get to that point, the next step is to get it out of the third hand. If you let it cool too long, you can see that flux will crystallize and attach to the tweezers. Typically, you can just break it off. Sometimes you might think that you soldered your piece to the tweezers, which can happen. But the next step now is to go into the pickle, which is the crock pot. There's a chemical inside there that we just drop our pieces in, and the pickle will clean off our pieces for us. So that's the perpendicular joint. Okay, so I have the large disc in the third hand, and the small disc I've placed just on this honeycomb block. We are going to flow solder onto the surface of the small disc. And we don't have to have 100% coverage across that disc, but we need to get a good puddle going because when we flip that over and put it onto the larger disc, we're going to reheat and get that solder to flow from the small disc that we just coated and get it to then join with the larger disc. So eventually you're gonna have full coverage in between the 2 pieces of metal, but you have to have enough solder to get full coverage. Ideally, what we're looking for is a little perimeter of silver around the entire diameter of that small circle. So, and if we apply the solder to the smaller circle, we don't have the possibility of solder puddling beyond the surface of that smaller circle, so you don't see puddles around the perimeter out here, because the solder, it doesn't just keep running. It's not a seam out here, so it doesn't continue to flow out to that bigger circle. So if we apply it to the large circle, then you do have that risk that you may have solder puddling in places that you don't want it. So that's why we always apply to the small circle. Rather than cutting the solder to drop onto this circle, I'm just going to feed it in. So I'll be heating the small disc, and I'll just be feeding that wire in to create a nice little puddle. We'll just see how this goes. It's hard to tell you exactly how much solder to use in this circumstance. So we'll just kind of go for it and see what happens. All right, so I'll start to heat. Again, we're going to go through the phases. Here we're coming up on powdered donut stage. And as that glazes over, we'll get into glazed donut stage. And once that flux starts to glaze over and kind of lay down and flatten out, then I know that we're coming up to soldering temperature, so I can start to introduce the wire. And there it starts to puddle and flow. So now I can just kind of paint this on that surface. Okay, that is probably more than enough, but you can see I don't have full coverage across that whole surface. But I do believe that that's going to be enough. Okay, now I need to apply the flux to this surface as well. Like I said, copper doesn't really care if you flux the entire piece, but I just do anyway. And then we'll start to heat from underneath. Now, thinking about the mass, the larger disc is where the mass is. So I'll get that up to glazed donut stage. This is right about there. And now I can drop my other disc in place. I'm going to grab my pick and just push it around. Now, the problem that I have with sweat soldering is that you have this thickness of solder in between the two pieces. The weight of that top disc is going to settle down as that solder flows and push that solder out to create full coverage in between the two pieces. It is also sort of slippery. So the problem that can occur is that top disc can slide a little bit. So I have my pick close at hand in case that thing moves someplace that I don't want it to. But normally what happens is you can kind of see that top disc just kind of settle down and find its home. But it can be a little bit slippery and it can move around on you. So let's just watch this happen. There it went, and it actually did. It slid just a little bit, maybe a 1/16 of an inch as that solder flowed, but I think I have full coverage all the way around. So I can take my pick and just run that around and look at it, and I can see silver all the way around the perimeter here. So that's a sweat solder. Not my favorite type of solder joint just because of that movement that can occur, but it can be a very useful way to solder. So the third and final solder joint that I'm going to show you today in this video is the butt joint. The most common use for the butt joint is when you're making a ring. You typically start out with a continuous piece of metal, whether it's a piece of sheet or ring sizing stock of some sort. But what you do is you end up bending that piece of metal around, and the two ends get soldered together, and that is a butt joint. You can also take two pieces of sheet metal and solder those edge to edge. That would also be a butt joint. Okay, so I have my strip of metal that I'm going to bend around into a ring. At this point, I don't care about sizes. We'll talk about sizing for particular ring sizes in class. But for just demonstration purposes, to create a ring to solder together, I've just taken a strip of metal, and I'm going to use my mandrel. I've got it set up in my vise, and I'm going to use my mandrel to drape this material around. So I've got a mallet here, and I just do these kind of glancing blows
over the mandrel in order to get this material to wrap around the that shape. So once I get to this point, I really don't care about the shape. I don't need the material to be completely round, but I get to this point, and I call this the lowering the drawbridge phase. Okay, at this point, I have the two ends coming together. They kind of look like a drawbridge closing. And what I'm going to do is I'm going to lower the drawbridge. I'm just going to tap one side, then tap the other. And I'm just bringing them together. Take a look at it from the top down. If they're a little bit uneven, this is the time to address that. Get those ends in position so that when you drop these two down, they're coming at one another. One of the little tricks that I like to do when I'm closing a ring is this is closed, and I think I could solder that. But if you're having trouble getting that drawbridge to close nicely, quite often if the material is thin enough, you can give the ring a little bit of memory where the two ends are overlapping just a little bit, and then you can just spring them apart and get them to snap down on one another. And that tension within the material will hold that seam closed. Again, now is the time to get things in alignment. If you're really having trouble getting the two ends to kind of come together nicely, you can take your parallel pliers and just across that seam, just grab on and squeeze down, and that will typically help align those ends so that they're ready for solder. When you are shaping this material, again, at this point, this is just a demo. These are samples that you're making just to learn the process of soldering. But you do have to make sure that these ends are nice and straight. If you cut them with the jeweler's saw, that can produce kind of a wavy edge. Take your file and just file across both of those ends to create a nice flat surface, and then bring those two ends together. And you can see that this is not a ring. It's not a round ring anyway. And that doesn't matter. We solder it like this, and we will shape it after the fact. Okay, so we have formed our ring. It is obviously not round, but we do have the ends coming together nicely. So at this point, we're ready to solder. What I'm going to do is I'm going to place it in my third hand. I'm going to grab onto the ring from the top, which is the side that doesn't have the seam. So the seam is actually on the bottom here. What we can do then is flux the entire piece and then place our solder inside the ring so that if it puddles on the inside and you don't notice it nearly as much. A little harder to clean up, but better to have that puddle on the inside than the outside. And we'll lay our solder right on that seam, heat from underneath, and get that solder to draw down through the seam. So here's our flux. We will bring in the heat. Powder donut. Glazed donut. We're ready for our solder. Again, you can use a pair of tweezers to place your solder, but if you can get good with the pick, it just eliminates that extra tool and having to set your pick down, pick up the tweezers, set the tweezers down, pick up the pick. And rings can be a little fickle. I like to keep my pick real close because if the solder does not flow into the seam right away, I can usually push that around to get it to run into the seam. And I think we are good. Let's take a look from the bottom. And we can see, I don't know if it's hard, it might be hard to see on camera, but I can see the seam is closed up and there is a nice silver line down here. So that is how we solder a ring together with a butt joint.
Okay, so those are the 3 basic solder joints that we'll learn from this video. When you're learning to solder, you need to practice, just like anything. I mean, none of this is intuitive. Just because you have one successful solder joint doesn't mean that you should stop. Practice, do 2 or 3 perpendicular joints, do 2 or 3 sweat solders. We make a lot of rings in this class, so make a couple of sample rings with the butt joint. Get in here, spend a few hours learning how to solder. Once you build these individual samples, try soldering those things together. So then you'll have, a single solder joint here, a single solder joint here, bring those together, and then you'll have 3 solder joints in a single piece. As we're constructing jewelry, we're making complex pieces with multiple solder joints. This is a good opportunity to try bringing multiple components together, stepping down with your solder, using the hard solder first, medium solder next, and kind of working your way through the system. Everybody learns to solder. It can be challenging, but use the beginning couple of weeks here in the term to build those skills. It will benefit you down the road as we get into more complex projects with multiple facets to them. So get in here and practice, and happy soldering.